Students, good morning. Today I am going to discuss about the Linde liquefaction process, construction and the working principle of Linde liquefaction process. This Linde liquefaction process is also known as Joule-Thomson expansion. The process is also known as Joule-Thomson expansion or Isenthalpic expansion. Linde liquefaction process is also known as Joule-Thomson expansion or Isenthalpic expansion. Let us start how to construct this Linde liquefaction process. What are all the key components? Number 1 is compressor. Number 2 cooler. Number 3 heat exchanger. Number 4 expansion device. Number 5 liquid. Number 5 flash drum. Number 6 liquid receiver or safe storage tank. Number 6 liquid receiver. Number 7 reunion valve. 1 is compressor, 2 is cooler, 3 is heat exchanger, 4 is expansion valve, 5 is flash drum, 6 is storage tank, liquid receiver, and 7 is the reunion valve. Right. Number 1 compressor. Compressor is used to compress the air is about 200 atmospheric pressure. Compressor is used to compress the air to about or near about 200 atmospheric pressure by decreasing its volume. Decreasing volume, which in turn increases its temperature to a great extent. Temperature increases drastically. Compressor is used to compress the air is about 200 atmospheric pressure. Due to compression, volume gets decreased or compression by decreasing volume. Decreasing volume, which in turn increases the temperature of air to a great extent, drastically. Clear? Right. The highly compressed air is fed into a cooler. To decrease its temperature to a level of room temperature. The compressed air is fed into a cooler to decrease its temperature to a level of room temperature by spraying cold water at the top, and the warm water is rejected from the bottom. Clear? Cooler is used to decrease the temperature of compressed air to a level of room temperature. Okay. The high pressure low temperature air from cooler is fed into a heat exchanger, that too in high pressure section. It is fed into a heat exchanger, that too in a high pressure tube side. Okay. In this heat exchanger, the temperature of high pressure low temperature air will be decreased by using the return air from the flash drum. Still, the temperature of high pressure low temperature air is decreased. It is near about to liquefy or about to liquefy. It is ready to liquefy. The temperature is decreased drastically near about minus 140 degrees Celsius. Minus 140 degrees Celsius is the critical temperature of air. In heat exchanger, the high pressure low temperature air is fed into a high pressure tube which is located in the heat exchanger. Here the temperature of this high pressure air gets decreased drastically by using the low temperature low pressure air from the liquid receiver or flash drum. Clear? This low pressure air is used to decrease the temperature of high pressure air. This is called as pre-cooling of highly compressed air. Pre-cooling of compressed air. This process is called as pre-cooling of compressed air. The temperature of compressed air decreased to a level of near about minus 140 degrees Celsius. This is the critical temperature of air. Now the air is ready to liquefy or about to liquefy. Once the air enter into a expansion device. See this expansion device. It has three sections. One is convergent section, narrow down, convergent section. Another one is throttle area. This area is throttle area. This one is divergent section. Divergent section. Convergent section, throttle area, divergent section. Once the compressed air, highly compressed air, enter into the expansion device, first it experiences an increase in pressure because it is a convergent area. Increase in pressure. Once it crosses the flow restricted area or throttle area or porous plug, this area, once it is enter into the or it crosses the throttle area, all of a sudden this compressed air will be expanded very short span of time, very sudden expansion. The expansion becomes sudden expansion. Due to sudden expansion, the temperature of air decreased below the critical temperature of air. That means minus 140 degrees Celsius. The air temperature of air will be decreased greatly, will be decreased drastically below the critical temperature of air. Hence, the air will be liquefied in the divergent section. Clear? Now, major share of air gets liquefied. Major share of air gets liquefied. Okay. Air. Now it is called as two-phase mixer. Liquefied air and unliquefied air. This two-phase mixer enter into this flash drum. Flash drum is used to separate the liquefied air and unliquefied air. Unliquefied air present in the top, liquefied air present in the bottom. The liquefied air is sent into a liquid receiver or liquid storage tank or safe storage tank. The process is over. Okay, what about the unliquefied air? Now the unliquefied air is low pressure, low temperature. This is fed into a low pressure tube side. This is used to pre-cool the high pressure, low temperature air. This is regenerative heat exchanger. This is called as regenerative heat exchanger. Okay, now the process is over. The air from low pressure tube side, after pre-cooling the high pressure air, it is sent to a reunion valve where fresh air is reunited. Fresh air is reunited and the makeup air is again fed into the compressor. Clear? This is the construction and the working principle of the Linde liquefaction process. Linde liquefaction process is also known as Joule-Thomson expansion. Joule-Thomson expansion means when a compressed air is allowed to expand or allowed to pass through a throttle area or a porous plug or flow restricted area or a partially opened valve, it experiences a decrease in temperature due to expansion. This is Joule-Thomson expansion process. Clear? So, Linde liquefaction process is also known as Joule-Thomson expansion or isenthalpic expansion. Listen, in this throttle area or expansion device, the expansion happens within a short span of time, very short span of time. Sudden expansion. Due to sudden expansion, there is no suitable mechanism to convert the heat energy into work. Heat energy into work. So there is no work done by the system. There is no work done by the system. Clear? There is no work done by the system, and the expansion is assumed to be a adiabatic one. Since there is no work done by the system as well as adiabatic, the enthalpy of the air remains constant. Hence it is called as isenthalpic expansion. Enthalpy is constant due to there is no work done by the air due to sudden expansion. Clear? Enthalpy is constant. There is no work done by the air. Adiabatic system. Hence, the expansion is also known as isenthalpic expansion. This is the construction and working principle of Linde liquefaction process. Clear? Thank you.